Okay, if we move on to example 2, I'm going to show you 2 places you can cut corners on the quadratic formula that you might prefer to do it this way. It's up to you. First thing, this one right here doesn't start off in proper form. Very important. Again, everything descending order equals 0. X squared being positive is easier than x squared being negative, so the fact that x squared is negative, I'm going to move everything to the left. If that was a positive x squared, I would have moved the 6 over to the right. So negative x squared moves over, becomes positive x squared. Positive x becomes negative x. Minus 6 is staying where it's at, stays minus 6 equals 0. Now there are no numbers in front of the x's, but there's officially a 1 in front of x squared and a 1 in front of x. So the fact that we have to use these numbers, it's sometimes helpful for students who are just first doing this formula to actually put the coefficients of 1 when they're not written. Okay. First corner you can cut, I can see what a, b, and c are without writing them down. So if you don't want to write a equals positive 1, b equals negative 1, c equals negative 6, that's perfectly fine with me. No problems there. I understand fully. I personally don't write those myself. So if you don't want to write those down, if you can mentally know that's a, negative 1's b, negative 6 is c, just be careful though that b and c are both negative in this case. The other thing is I go directly to the answer myself. I guess that's the biggest corner you can cut, right? Go straight to the answer. Okay, of the 3 locations, which one's hard to do? The second one, right? The b squared minus 4ac, right? So b squared minus 4ac, I'm going to do that over here, figure that out. All right? So b is negative 1, so what's b squared? Say it louder.
1.
1, very good, positive 1. All right? No matter what b's value is, you square it, you're going to get a positive because you're multiplying it by itself. 2 negatives make a positive. And then minus 4 times a, which is positive, 1 times c, which is negative 6. Minus minus makes positive. 4 times 1 times 6 is 24. 1 plus 24 is 25. Okay, so 25 goes in the square root. The other 2 things I have to find, I can do those without writing them down on a piece of paper. Minus b means change the sign. b is negative 1, I put a positive 1. 2a means double the number. a is 1, double that is 2. So I get 1 plus or minus the square root of 25 over 2. What's the square root of 25? Okay, in this case, since the square root was an exact square root, I would expect you guys to evaluate that down to a nice whole number. And once it's evaluated to a nice whole number, plus and minus means to add and subtract. So if I add 1 plus 5, I get 6 over 2. If I subtract 1 minus 5 is negative 4 over 2. And that gets me positive 3 and negative 2 as the answers to this. Now what you might recall from what I told you yesterday was factoring is always quicker than any other technique. That wasn't too bad, right? The quadratic formula. Completing the square. Let's take a look at that. Had I completed the square, it would have looked like this. X squared minus x equals 6 plus 1/2 squared plus 1/4. That's going to be x minus 1/2 the quantity squared. 6 plus 1/4 is 25/4. You get x minus 1/2 equals plus or minus 5/2. So x equals 1 plus or minus the square root of 5, or sorry, plus or minus 5. One more square root there. 1 plus or minus 5 over 2, which gets us to the same answers, right? There's the completing the square technique. Here's the quadratic formula. Here's what factoring will look like. X minus 3 times x plus 2 equals 0. So x equals 3 and negative 2. Factoring is quicker. So for me personally, when I see solve a quadratic equation, and I already have it in descending order, can I factor it? And if I can, change the sign, there's your answers. But again, the quadratic formula gets these answers. The completing the square gets you those answers. Factoring gets you the same answers. Okay, factoring is always the most efficient if you can figure out how to factor it quickly. If not, quadratic formula and then usually completing the square in that order.